We're going to take a moment to look at examples of physical properties, but especially how we can use in our world, or animals can use in the world, different properties of matter, either quantitative or qualitative properties. So let's see if we can look at some examples, because application is always important. So the first example I have is this polar bear that is hopping from one piece of ice to another. So here we can assume it's further north. We see it could be, I don't know if it's the spring. Let's say it's the spring because we have the ice that is breaking down. So here the polar bear is using the ice as a platform for hunting and being able to save energy. The issue lately with with higher temperature, we have the ice caps that are melting and makes it harder for polar bear to do their hunting and hopping from ice block to another, especially when there are no ice blocks. Now, what's interesting with this one here is that the density of ice is smaller than the density of water. So what happens if you are to do a drawing? If you have a lake like this in the summer, that's wonderful. We have here water level, and we have the bottom part. If it is 25 degrees Celsius outside, here it might be 2015. And if it's a deep lake, we have about 4 degrees Celsius in the depth. What happens though is that when you end up in the winter, and let's say negative here, 25 degrees Celsius, what happens is that the water starts cooling down at the surface. And then you end up with ice forming. So the ice is thin at the beginning, and the colder it gets, the thicker the ice will be. So here we have the ice like this, and then you have further down water temperature that are more or less remaining the same temperature almost year round at 4 degrees further down. So if some of you are wondering, how can we get fish, amphibians, and other organisms living in the winter, is that when the ice is forming, what happens here is that the ice is also protecting, it's like an insulator, and it floats because the density is lighter. It insulates the water under here. It allows organisms to live throughout the winter until the following spring, when the ice is melting and we can go on again. So that's an example of how we have density working for us. Very nice. There's an issue with this idea of density. Sometimes if you think of people in the world, so here, let's take an example that could be interesting. This one here. So this is, it is an image of commercial fishing. So here we have ocean water. If you have ocean water, let's make it a bit bigger. If you have ocean water, you have salt water. So here you have what we call solubility of water. Given a chance, water can dissolve a lot of chemicals. And here in this example, salt. Now it has a density. That's why sometimes people, if they have things they don't need, they just dump it in the ocean and it just sinks to the bottom of the ocean and people don't notice it. And that is sometimes a problem with pollution. Here we have fishermen fishing fish, which is important because humans are eating fish. However, the fish is growing and going from eggs all the way to maturity in the ocean water. So if it's just salt and some nutrients, that's beautiful. But if we have pollution or polluted water, what happens here is that the chemicals that are easily dissolved in the ocean water ends up in the habitat of the fish, and then you end up with chemicals that can end up into our own body. So the solubility is amazing, but it can be an issue. If we have pollution here, it goes into the food chain and it affects us. An example of that, we always say that if you have a pregnant woman, we want to limit how much tuna that person eats, maybe 1 can of tuna a week, because sometimes tuna, which is higher in the food chain, would have more chemicals in their flesh, and therefore it can affect us. An example of solubility, we have acetic acid dissolved in water. That's amazing. I had a coffee this morning. We were able to dissolve some of the flavor in the water. That's amazing. When you use it, that's great. But when it ends up in the environment and its pollutants are increasing in quantities, then it's hard for the oceans, the lakes, the rivers, and so on. So that's something to look into. Another example would be the pollution of air or air pollution. If we have manufacturers that are creating things, they need heat, they create pollutants, and then they can end up in the air. The solubility of pollutants and gas in the atmosphere is quite high. And that's why we have sometimes polluted air. If it's localized in one spot, for example, we have smogs in some areas. If you have, so I'll show you an example. Here's an example of air pollution. A couple of years back, we had forest fire one summer in Canada. They were in large areas. It affected, and then I could see the sun like this, and I could smell the smoke in the atmosphere. And actually, it covered part of Eastern Canada and Western Canada, and this even went into the States because the air can dissolve a lot of particulates and keep things in suspension. So, atmosphere, gases, fluid like water, they dissolve greatly. However, even though it is a great physical property, it can be detrimental if we are gathering much more of it. So that's something to look into. Another example, so here's an example of tailing in a mine site. So here's a situation where if you have a mine and you're extracting resources, what happens here is that you have water dissolving some of it. And if you don't treat this water, this can end up in the environment, polluting groundwater or going into rivers, which is unacceptable. And these are examples of what you can think of. So we talked about viscosity, the melting point with the ice, density, conductivity. So here, if you think of the conductivity of copper, this is quite great. It conducts very well. It has a certain price, but it makes it viable for extension cords and all the wires in our home. However, if you have very high voltage transmission line, often we're going to use aluminum instead of copper into their wires. And the reason for that, so if you look at the periodic table, right here and right here, so aluminum is right here with an atomic number of 13, and we have copper with here an atomic number of 29. Now, if you look at the atomic mass, we have here 26.98, about 27, and we have here for copper 63. So aluminum is about half the weight, half the mass of the aluminum. So that means that if you have large transmission lines, it's so much easier to use aluminum in the wires. Even though it conducts a little bit less, it's not as dense, and therefore it's easier for all these wires that are hanging from pylon to pylon. So that's something to look into. Nice. I'm going to give you other examples about how we can use, how physical properties can affect our environment and how nature is. So let's see. I always like those. So here you have daffodils, and here you can see we have plants. So we have a tree trunk here, which has a hardness, allowing the plants to reach as high as possible towards the sun. Here we have qualitative physical properties. We have the colors attracting insects for pollination indeed. So that's always beautiful. Here's an example of dandelion. Some people love them. There's some program in Quebec where they were trying not to cut dandelions. I think it was in May, so that it's good for the pollination and also for the honey industry. And here, once it's in seed, it looks something like this. Now, what happens though is that a lot of people don't like dandelions. So what do? They use chemicals to kill these plants, and that those chemicals end up in the environment, which is not good for other organisms and humans living in the area, and children's playing in grass. So here it's something that We can enjoy nature. We have here a flower that is yellow, but we have to make sure of the chemicals we're using so we don't pollute the environment too much. Here's an example of, here it's called an Eastern newt. I saw that a few months ago. That was in the spring when I went for a hike. They come, so they're eggs in water. Then they come into larvae, and when they're teenagers, they're orange. And when they end up adult, they are grayish green in colors. But what happened here, we have skin that is very porous. And when you have eggs of amphibians in water, if you have pollutants in the water, it goes into the eggs. It could have malformation of these organisms. If there's acid rain, the acid rain will be very difficult and very hard for those amphibians here. So here we have to be mindful of what we put in the environment. And here, keep in mind that the environment always recycles the materials. So you could see all around how we can have materials that are starting to rot, to recycle the matter, to go and create new pieces of matter. This is the trillium. This is the flower of Ontario, and you could see the dead leaves here. The dead leaves here are solid, but if you start at the end of the summer, they will have all decomposed and bring new nutrients in the environment. So here, this one I took, these are tulips. They're always nice. The dark is very hard to get very dark flowers or black flowers. I thought it was beautiful. Keeping in mind here the color, which is a qualitative property, is one way to attract here pollinizer, and here humans that love them tremendously. Here's a picture here of, it's just of Lake Ontario. You can see here the atmosphere and the fog in the atmosphere. So we have a gas, you have here water vapor, you have here the water right here, and you have the rock. And this is a hard surface where terrestrial ecosystems live, and humans as well. But keeping in mind that if we're not taking care, we can pollute the atmosphere very easily from human activities. We can pollute the waterways, lakes, and river because of human activities, and also the land here. So when you're thinking about chemistry and the environment, always try to see, is it possible to refuse to use some chemicals? Is it possible to reuse? Can we recycle what we use to minimize what is in the environment? Can we, let's see, what is the other one? Could we repair what we are using so we can create less waste? All the things to keep in mind with respect to environment and chemistry. This one here was one morning. Actually, it's the same morning as the previous picture with the fog. This was a plant, and you can see here the property of water. You had water vapor in the air, and here you have a condensation. So we have here little molecules of water that were on the plants, and they attract each other. And then you end up with larger and larger beads on this. Isn't it beautiful? It's always nice to see different defined nature. So here you have surface tension, properties of water. You have here condensation, which is the going from vapor to liquid at 0 degrees Celsius. We also have the colors, we have light reflections, a lot of observations here. So here we have a rabbit. The reason why I put it there is to keep in mind that when you have a food chain, if you are putting chemicals in your lawn to be able to keep it nice, or if so the rabbit here, when they eat plants, they eat food, whatever goes into their food ends up in their body. And that can create a situation where there's an accumulation of toxins in their body. So that's why we have to be mindful of the chemicals we use and their property. Here's a golf course here. This is amazing. Keeping in mind that in this one here, there's a bylaw in the town of the type of products we can use, because here there are no houses because of the valley. However, we have a river, and the river collects whatever chemicals will be put on the golf course, and the river ends up in the lake, and it is a source of pollutants. I know that the river is fairly clean, even though, because if you go up, it goes up further north from here, like many kilometers, and every kilometer the river flows, it can collect pollutants. So we have to be careful of our rivers. This one here, another flower. Loving the colors. This one was, let's see, it's coming. You'll see. It is a butterfly in one of my walk. Get closer, closer, and there we go. Look at how beautiful this is. So insects, they will be eating plants or they will eating other insects. And what happens here is that they are at the basis of our food chain. And if we appreciate nature, we need to make sure that the environment is as nice as possible, not just for the organism, but for humans as well. The better the environment for all organisms, the better it is for us and the better our health as well for now and future generations. And here's an example of a tree. So these are cedar trees, and look at how the roots here. We have a tree that is growing on these rocks, but then it needed more resources, more vitamins, more minerals, and more water. And you could see how we have the roots that have been expanded. So here we have to the right here a lake. I don't have it on the picture. It just shows here how nature is working very hard to work. Now, keeping in mind that if the water is not as clean as possible, here we have a tree that has difficulties. If there's pollution in the soil, it's harder for the plants. So we have to keep that in mind. And here's the last one. Here, so I went cherry picking last summer, and it's just to show here with respect to physical properties that are qualitative. Qualitative properties. We have here the cherries that are very nice and red. They're appetizing, so we want to eat them. We have here the green leaves, where photosynthesis happens, because all leaves for the most part are green where photosynthesis happens. Environment has to be great because those leaves are picking up the carbon dioxide from the environment. That means that it's cleaning our environment. It's also producing waste, which is oxygen, which we use, which is amazing. So here again, if we have an environment that is good for those fruit trees, the fruits are better, and then our health is better. And keeping in mind that sometimes we're using chemicals to protect these fruits from some insects or some animals, and therefore you have to always wash them if you wish. And here there's another picture. It's always nice to see. So here is a many cherry trees right here. And as you can see, so here there's no grass under here. So the chances are is that either they are putting chemicals to kill all the grass, or they put the tarp during the winter so nothing happens here. And here, as you can see, there's no plants that are undesirable. So the chances are that they're using chemicals to keep this orchard nicely. If they use chemicals, they need to be mindful of the ones they use, because we don't want the chemicals to end up in the water, in the tree, in the fruit. And where goes the fruit? We eat them. So you always have to be mindful of what you're doing. And that overall summarizes how physical properties of matter is very important. And in chemistry, it's also very important because these characteristics makes it that chemicals ends up in our food chain, in our environment, and we want to avoid any of those things. On this, if you have any clarification questions, put them in the comments below. And I will put here another video that will be about chemistry, and I'll see you there.